Okay, we're going to continue. I need 2 groups to participate in the technical naval engineering student technical sessions, 2 groups. If your group is willing to participate, fine. Otherwise, I will choose randomly. Also, I need 2 persons to participate in the roundtable. This roundtable is, I think, is very interesting, and I would like to see it participate in these roundtables. People from outside the Guayaquil, different area, women. So it's going to be we're going to get a first-hand impression of the problem. That's what we need. And don't worry, we are not going to let you talk and talk and talk. We're going to give you 2 questions. So you can think about that 3 or 4 days. You can talk to your friends to see that they can help you. So you will have participation, say 1 minute to explain the first question. We're going to go around, and then we're going to do a summary of that answers. Then we're going to go to the second round. And at the end, we're going to have some minutes. So if you can say something, that's fine. So that's all. But the idea is that we bring this info to the community. Okay. So let's go now to the breakout rooms. Okay. Everybody, please go to your breakout rooms. Genesis, you work with groups 1 through 4. Isaac work with group 5 through 8. Now we'll go to the rest. Okay. If you want, it could be a good idea if you start by the last one that you checked last session. So they will have more time. And at 9, we will go back.
Hi.
Good morning. Good morning.
Good morning.
Who is,
Hi, Doctor. Good morning.
who is the leader of this group responsible?
And Joyce.
So responsible is,
Okay.
okay. Tell me, is your model ready?
Yes, it is ready, Doctor. But I don't know if you remember that I told you the first reunion that we wanted to work both on the design. I made mine. I don't know if you would like to see the arena design. We both made ourselves the designs, and yesterday we tried it. So we choose my partner one because he had like the most details in the Reno design.
But
His.
right now, that's something that has to be done already. Right now, we should be
Yes, it is.
ready. Can you show me
We're-
your Rhino geometric model?
One moment, please.
I'm sorry. Yeah.
Can you show the screen?
Yes.
I don't know if we did it.
Yes.
Okay, go on. Okay, here, yeah, I see. I can see it.
Yesterday.
Okay.
Yesterday, I made the mesh.
Okay.
You can see the mesh.
Are the connections correct? Are they connected?
Yes.
Can you
Yes,
zoom?
Yes.
For example, can you zoom the deck with one of the pillars, so I can check that. Just
I use the, how do you say, herramienta? I use the
tool.
I use the other tool that you can select all face and the program connection all these super.
Okay, good.
Yeah, the you can see the connect is all elements in the structure.
Now let's go to the loading conditions. What are the loading conditions that you are going to consider?
The loading condition.
Yes, let me share real quick. Okay. So for the loading conditions, we were thinking and apply the static load conditions, where we are going to apply the general loads that are already on the design, the hydrostatic load, and the standard gravity load. That's for the first case. These are the loads that we are going to apply.
Now, that's one. So what you're going to consider the same weights, but with the original and with the corrosion effect, right?
What we wanted to do is we wanted to do the static load, but we want to analyze in two cases for the corrosion part. Okay. We wanted to do the same analysis, but with this Lloyd rule, we want to analyze for the 30% of some elements and the 25% of corrosion allowance.
Okay.
The same structure. And then we are going to analyze the influence of the dynamic load, the one of the weights, the wave load. We calculated and we get a load of 125.8.
Okay, let's go in steps. Okay, let's do apply the load for the first case. Okay. Get convergence, check results, and then you're ready. Let's go to the second loading conditions. In that case, you don't need to check convergence because you are using something that we rely. You don't need to check the results. So you have to, if you have time, go to the third loading condition.
Okay.
Go in steps, okay?
Okay, Doctor, we have a question. Because of the two designs that we made, when I made mine, I thought that maybe because the side that we have to analyze that is in the main room, the decks in between main rooms, I thought that maybe we don't need too much structure. Could be like a good idea if we just analyze the two deck sides with the two decks without the side to see if there is necessary that we use it.
See, you can decide, but I would like to see, for example, you see the full structure, and let's suppose that you concentrate in the intermediate deck, the one that you are showing here in this figure, okay, the intermediate deck. Okay, now, why don't you analyze that without any borders? Okay, just
that's what I was.
Yeah.
Yes.
But then analyze the whole thing and compare, and you can conclude if the adjacent structure, how much influences in the analysis of the deck that you are analyzing. So
that
you
was
analyze the whole structure with the deck and the original load. Then analyze the same structure, only the deck with the same load. And according to the results, you go to the second loading condition. If you see that there is a large difference between these two results, that means that you have to analyze the whole structure, and then you reduce the corrosion effect. So try not to just answer an academic exercise. Try to do a professional exercise. Okay?
Okay.
5 minutes now. Good work.
Okay.
Keep up.
Good.
Okay. Thank you, Doctor.
You're welcome.
Hello, Doctor, you're mute. Doctor, you're mute. I can't hear anything.
Please turn on your cameras because I'd like to see you. Please show me your model. Show me your model. I want to see your model, please. Model.
I'm sharing right now. I don't know. Yes.
Okay, I can see it. Good. So you have to analyze the what?
We have the collision head from a supply vessel. We have a boat. The plans had a little problem with the scale and dimensions that we managed.
Okay, good.
The collision bulkhead is the blue one.
Okay.
We made.
This is Rhino.
Yes.
Did you import it from ANSYS already?
No, not yet.
You are behind. You are behind because you are supposed to have it by now. You have to import it, and then that's something that which takes a lot of time. It's to make certain that all the elements are connected. Yeah, that's a headache for the analysis. Okay, so you are behind. What loading conditions are you planning to apply?
The clamped. As yesterday, Engineer Onofre said, that would be the worst conditions because we are restricting movement and we stress more the model.
Okay, it could be a good idea. There are many possibilities here. For example, it could be a good idea, for example, if you apply the load up to, for example, 75%, but no external load. Okay, it's like having the ship on the dry dock. In that case, yes, there is no water pressure. But also, you could
when
consider
75%, because 75%.
I don't think if you go to you take the ship to the dry dock, I don't think you are going to have that compartment full of water.
But also it's empty when it goes up.
Let's suppose that for some reason you have to put some water because to equilibrate or improve the trim of the ship. Okay, so I think it's a pessimistic idea to consider that it's 75% full. But in general, I would expect it to be empty. But in some cases, it could be possible that you put some water in order to improve the trim. And if you put it on the dry dock, there is no pressure from outside. That's one case. And the other case would be full inside, but also applying pressure from outside, which is floating. And you think it's as this compartment is completely flooded. So you apply pressure from the side and also pressure perpendicular to the bulkhead. People, you are behind. You are behind. Okay, bye now. I didn't see Mr. Diaz. What happened with him? You're here? Okay,
Estaba viendo. No.
Doctor, good morning.
Good morning, doctor. Good morning.
I don't listen, doctor.
You have the structural model complete?
Yes.
Yes.
Okay,
I have the.
Okay, so please turn on your cameras because I need to see you. Okay. Okay, so the model, ANSYS model is complete. Did you check the connectivity between the elements?
I have little error, doctor.
Okay.
We have the problem is the connection in the structure. In the problem with the mesh.
Yeah, I know. It's a big problem. How many elements do you have right now?
Elements.
More or
Please,
less.
Did
you make it? Did you make it run? Did you make it run? Did you make it run the program? The ANSYS program, did it run?
One moment.
No, I don't want to see the result. I'm just asking if you, because it's a good idea. Okay, if you just put some boundary conditions, put some load, and make it run, see if it works. Okay, so then you're trying to, in the end, after that, you can select this, select that. Okay, people, tell me, how about boundary conditions, loading conditions? What are the loading conditions that you're going to apply? Loading conditions.
Loading condition.
Okay.
The condition is the condition normal and the condition with the thickness minus 1 millimeter and duplicate the chair.
Yeah, but why you duplicate the loading? I mean, it's I think it's an extreme. That's not unrealistic. Okay, if you think that that's a maximum load, that's a maximum load. You don't need to apply extra load. Okay, so you consider the original and then reduce thickness. Now, why you say that it's 1 millimeter less? Why did you get that?
Is the all screws.
Me?
Yes, and the flange,
Yeah, but no. My question is, what is the source? Who told you that you have to reduce 1 millimeter? Why not 2?
What is result?
What's the reason? Yes. You have to explain why you reduce 1 millimeter instead of 1.2 or 25%. That's not something that you just have to invent. You have to look for in the literature and see what's the recommendation from a classification society. Okay, they told you, for example, you have to reduce, I don't know how much. And you say, from that chapter of that rule, I'm going to reduce these things. That means that this plate is ready to be replaced. And at that point, you have to be certain that the loading is not going to produce any permanent damage to the structure. but that's not something that you have to invent. No, it has to be official. I'm not going to accept that. You have to justify that.
Doctor, it's possible we have information the solid, for example, in the
Yeah. There's no problem.
structure
No
and
problem.
the ship.
No problem.
It's about the time.
No problem.
We
But
have work
the thing
in
is
this
that
condition.
the thing is that you have to be very precise. Okay, you have to say, in that chapter of that reference, they recommend this. And I'm going to apply that in my analysis.
It's possible I can speak about the less 1 millimeter reduce in all structure. We respect the solar.
The thing is that, no, you have to, I mean, you have to be, see, the thing is this, there are other references that tell me that the reduction is higher than that. So you have to find the references and look for and complete it. Would you please turn on your cameras because
Yep.
Okay, can I see your model? Can I see your model, please?
Can you see the screen?
Okay. Okay. Can I see a Zoom to check the connection? So they are connected, right? Yeah, it looks like they are connected. Do they include these triangles in the connections?
Yes. More near,
Closer, closer.
more close.
Okay, good. It looks like they're connected. It looks like, good. What are the loading conditions that you're going to apply? The loading
We are going
conditions.
to apply the pressure
The pressure in the deck.
on the deck that is given in the
plane.
PDF.
Yeah,
24 kilonewtons.
25. 20.
Only pressure. And then what's the second loading condition? My suggestion is this. Why don't you take 3 loading conditions? First, only with the lateral load. Second, with the axial load because of
For
hugging and
moment.
sagging, bending moment. And the third would be with both lateral and in plane.
Oh,
Okay.
okay.
And take
Yes.
the reduced thickness situation. That's my suggestion. Okay, so you have the structure, you have the load on the deck, that's one condition. You have the hugging, applying, for example, compression on the deck, that's 2. And the third will be both, applying lateral load and in-plane load. That's very interesting to see if, for
Okay.
example, what is the effect which causes the most impact on the structure. Okay, people.
Yeah.
Reduces the stress. It reduces thickness. Okay.
Reduce.
Because-
Did you
yeah.
say reduce?
Okay. You can either choose if you have 3 loading conditions, right? You could select, you want to analyze the structure as it is built with the original thickness, or you can analyze it with the reduced thickness, because it's going to be too much. It's going to be too much. So you either select this or that. But in that case, either one, I think it's a good idea to see if you, when you apply the lateral, the in-plane, or both, what is the worst situation? So that's something that we need to check. Okay?
Okay.
Okay.
Good.
Yes.
Good.
Doctor, you mute.
People, do you want to participate in Naval Engineering Technical Student Sessions, people? Somebody? No? Well, in that case, I'm going to select randomly who is going to, okay? And I'm going to announce my decision by tomorrow, because I have to consider both, okay? Who is going to participate in sheet vibration, mechanical vibrations, and who is going to participate with finite elements. Both have to participate. So I'm going to select that. So I'm going to select some groups from here, some other groups from mechanical vibrations, and some groups for the roundtable. Ms. Larrea, can you hear me?
Yes, doctor.
You are a good, you have a good profile for the roundtable, because you are women and you are from outside Guayaquil. Don't you like to participate? It's simple. It's just 2 questions to answer. That's all. No?
I don't know.
Come on. See, when you go on and you go to ship design, you have to do many presentations. And then you go to the integration project. Again, you have to do many presentations. Ms. Lopez, can you hear me?
Yes, doctor.
Would you like to participate in the roundtable? Again, you are a good, you have good profile for this participation. We would like to listen from you. So you're women from outside Guayaquil, and it's possible. It is possible that you felt that in some cases you were not included. So we would like to listen from you. And we would like to see if you have any suggestions to improve in this respect. So think about it, okay? Otherwise, yes, I will have to simply decide who is going to participate. Okay, people, on Monday, we're going to have an evaluation on the use of Rhino and ANSYS together to prepare an analysis of a simple structure. We still have not decided what structure we're going to analyze, but it's going to be nice, okay? That's Monday. Is there any other question, people? Is there any other question? We're fine, so go on with the project. No questions? Okay.
I have a personal matter in here. Will this be a little heavy so I can use my own computer, or should I already search another to borrow?
That's a good question. See, I'm going to make an announcement. It's up to you. It's up to you. See, it's like in a few years, you will be an engineer. And if you know that in your work, you have to do something extra for any reason, the easiest way to do is to prepare yourself. So if you need a cable and you suspect that it is possible that fails, you have to do what? You have to have a backup. If you know that the load that you're going to apply is well close to the limit, change the cable and use a stronger one, and you're safe. So it's up to you. On Monday, you're going to have an evaluation. I explained several times that we need to be certain that you are able to, you have enough skills in order to use the combination of Rhino and ANSYS in order to analyze an structure. So that's what we're going to do on Monday. We're going to check if that's true or not. So it's up to you. That's with 5 days in advance, I'm telling you, so you have to take your precautions. Okay, people? I'm going to do this announcement. I'm going to put it in the Aula Virtual. And also, tomorrow, I will post the selected teams that were going to participate in the technical sessions. So probably I'm going to select 2 teams from here, and I'm going to select 2 or 3 people from this class, and 2 or 3 from ship vibrations for the roundtable. And please don't think that this is I'm punishing you. No, it's just we really want to listen. See, we want the community to be aware of these problems. Bye-bye now. Have a good week. Some of the work, some of the groups are behind. And in my case, I explicitly told these groups that are behind. So please try to catch up. Bye.